All right, so we're going to talk about type checking briefly. So the idea here is that we're trying to we want to understand when working with a language if the language has strong type checking or weak type checking, or we would say that a language is strongly typed or weakly typed. So a good definition of type checking is this: operands of the operator are compatible. All right. So I'll give you an example of that in just a second. And so compatible means the operands might be compatible because they have the same type name, they have the same type structure, or we use some form of coercion to make the operands compatible. So here's an example from Java. So int a equals 0, int b equals 1, and double c equals 3.0. And then I say a equals b times c. And actually, we're going to make this C++, not Java. The reason why is that in Java this would generate an error because an attempt to downcast won't work unless you're explicit about the downcast. So what's going to happen here is the first operator we're going to look at is this one. And the operator is going to say, hey, B and C are of different types. B is an integer and C is a double. And so we're going to coerce B to double. So that's thing 1. This is thing 2. And then the result of this expression, because of thing 3, the assignment operator, the result of this expression has to be an int. So operation 4 is going to take the result of the multiplication of b and c, and to make that compatible with the assignment operator, because the left-hand variable is of type int, we're going to coerce that into an int. All right. So we have two flavors of major flavors of type checking. So we say a language is strongly typed, if for each variable has a single type. Boy, this is hard to write here. Single type. Oof, man. Single type. And that type is determined at compile time. And we always detect type errors. And there's no type coercion. That's the definition of a strongly typed language. So a question for you is Java, which you've been using since you started here at Stonehill, is that strongly typed? And the answer is not really. I mean, the formal definition of super duper strongly typed, it is not. because coercion is allowed in Java in certain circumstances. So it's not strongly typed. So I wouldn't say it's weakly typed, though. I wouldn't say, hey, Java is a super weakly typed. It's somewhere, I would say it's mostly strongly typed, with the exception of coercion for some simple data types. So weakly typed is basically not strongly typed. So it's going to violate the rules that are listed here. Now, you might be thinking that the only way to violate the strongly typed language in a language that looks a lot like Java is through coercion, but C++ allows a whole variety of fun ways of messing around with the type of a variable. So one way that I think you might find somewhat disturbing is through this sample piece of code. If I say void star p, what I'm saying is I want a reference to pretty much anything. That's what this says. Void is pretty much anything. So then I could say p is equal to new int. And then I can say star p is equal to 0x 66. No, that's not right either. I'm almost there. All right, 65, 66, 67, and 68. And then if I want to, I can say cout star char star p. P and L. So what this is going to have the effect doing is P now is essentially a typeless variable. It's a reference to pretty much any chunk of memory that I want to set up. I then immediately assign P to an integer chunk in the heap, and then I say that I want to dereference P and set that integer chunk in the heap to this hexadecimal number. And then I immediately turn around and say, forget that. I'm not going to treat P as an integer anymore. I'm going to treat it as an array of characters. And can you print out this array of characters? And so what it'll end up actually printing for output is A, B, C, D. So this is in C++. And I would say that C++ is still not... C++ allows you to use a lot of bad habits from C. Because in C there wasn't a mechanism for doing object-oriented programming, there are a lot of funny ways of dealing with manipulating data using the same variable for different types of data. So C is certainly more weakly typed than Java. And if I were to draw a little diagram here, I'd say Ada is very strongly typed, and Java is less strongly typed than Ada. C++ is less strongly typed than Java. C is less strongly typed than C++. And let's say JavaScript at the bottom is very weakly typed because we've got the ability to rebind variables to new types and new memory locations on the fly at runtime. And there's no way to do any sort of static type checking in any way, shape, or form. So this is strongly typed, and this is weakly typed. right. All right, we'll stop this.